So earlier we talked about range as a measurement of dispersion, and we said that there is a problem with that because in that we just look at two numbers, and if one of these two numbers or any of these numbers are extreme values, that can change the value drastically. But then for that we have standard deviation. Before we go through the calculation of standard deviation, let's understand one thing, that when we say standard deviation, this is also known as the sigma. Sigma is something which is the one which you see in 6 sigma. So when you talk of 6 sigma, you are talking of this sigma which is the standard deviation. So to understand 6 sigma, it is important that you understand the concept of finding out standard deviation. Because remember, 6 sigma is about variation reduction, about reducing defect, about consistency. So for that you need to understand this concept. So with this background, let's calculate the standard deviation of those same numbers. And these numbers are 104, 98, 90, 104 and 104. To find out standard deviation, there are a number of steps. Let's go slowly step by step and understand that. The first thing which you want to do is find out the mean of these numbers. So mean of these numbers is 100, which we have calculated earlier as well. You add these 5 numbers divided by 5, that will give you 100. So that's the mean. That's the step number 1 to calculate the standard deviation. The step number 2 is find out how much each of these numbers is away from the mean. So the first number was 104. How much is this away from 100? That will be 104 minus 100. The second number was 98. How much far it is from 100? That's 98 minus 100 and so on. So you find out how much each of these numbers is away from the mean. And those distances are here on the right, which is 4, minus 2, minus 10, 4 and 4. If you look at these numbers, and if you find out the average of these distances from the mean, and probably this is the sort of thing which we want to do when we want to calculate the dispersion, the spread, that how much each of these numbers is away from the mean. So this is the distance from the mean. But if you find out the average of this average is always going to be 0. Whatever numbers you have, if you take the mean of that and if you find out the distance from mean, then if you do the average of that, that will be 0. So here if you take the average of 4, minus 2, minus 10, 4 and 4, that will be 12 in plus and 12 in minus. The average will be 0. This will always be 0. So that's something which we cannot do. We cannot take the mean of that. Then what we need to do is we need to square that. Take a square of this. So take the square of 4, take the square of 2. The one thing which square will do is that after you take square, the sign goes away. The square of minus 2 is minus 2 multiplied by minus 2 is equal to plus 4. So what we do is we take square of that. Let's do that on the next slide. So here what I have done is I have taken square of all these numbers, all these distances from the mean, and the sign which you see here after 4 and 2, that is the sign for square. So I am talking about this sign here. So now the square of these are 4 square is 16, minus 2 square is plus 4, minus 10 square is plus 100, 4 square is 16 and 4 square is 16. So these are the numbers which I get as a square of the distance from means. Now if I take average of that, and let's do that on the next slide. So here I have that slide. So now if I take the average or mean of that, that will give me the variance. So I add all these numbers divided by 5 items, so that will give me the variance here. So variance is 30.4. Remember we talked about 2 measurements of dispersion, which we will be talking here, standard deviation and variance. These are connected with each other. Variance is the square of the standard deviation. So let me put it here. Standard deviation square is equal to variance. So this is something which we get as a variance. So variance is if you take the average of the square of the distances from the mean, whatever steps we have taken, that will give you the variance. One thing which you need to remember here is that you can find out the variance of the whole group or the variance of a sample. Just remember this thing. We will be covering this in green belt in more details, but just remember one thing, that if I tell you that these numbers were samples, then instead of 5, you divide it by 4, not by 5. If I tell you that this is the whole population, then you divided it by the number of items. That's something which you need to remember, n and n minus 1. Where you divide by n, when you are looking at the standard deviation of the whole population, you divide by n, and that's what we are doing here. But just in case, if you get an example where I say that this data is a sample data, in that case, instead of dividing by 5, you need to divide by 5 minus 1. Just understand that for now. Let's go to more details of these in green belt. So with this, now we have found out the variance, and variance is 30.4, and as I have said that variance is the square of the standard deviation. Now if I have to find out the standard deviation, what I can do is I can take the square root of this. The square root of 30.4 will be the standard deviation in this particular example. So here I have that statement, that square root of the variance is the standard deviation. So square root of 30.4 will be 5.51. So that is the standard deviation, and many times you can use calculator. So square root is represented by this sign as well, if you are not aware, but I am sure many of you will be aware of that. So if you need to take the square root of 30.4, so this is the sign which you put on that to find out the square root of this. So this was the standard deviation and variance. How do we calculate these? Most of the calculators, the scientific calculators, have this function built into this. So if you are going for ASQ exam or any other exam, you really don't need to go through each of these steps. You can feed these numbers and you can automatically get the standard deviation or the variance calculated by the calculator.